So can you see the screen?
Yes, sir.
Good. Ayan, nakikita na ba? So we go to the analysis of your T-beams and doubly reinforced beams. So in the analysis, parehas lang naman siya dun sa singly. Kaya lang dito sa T-beams, pagdating sa mga T-beams kasi, ang magiging problema is the location of your what we call this neutral axis. Wala. The location of your neutral axis. So may kinalaman kasi yung neutral axis pagdating sa T-beams. Like for this example, hindi natin alam kung yung neutral axis ba is within the flange or outside. Pwedeng andito yung neutral axis. Pwede rin andito sa baba yung neutral axis. So yun yung magiging problema mo dito. Pag sa taas, the compression is only carried out kung ito yung sa taas yung NA, the compression is being carried out by one only. Dito lang sa taas. So this is the tension. Ito is compression. While pag nasa baba yung what do you call this, yung NA, magiging dalawa yung compression mo. Meron sa taas. So it will be carried out with the whole flange. Then meron ka pang isa dito. So this is magiging C1 and this is magiging compression 2 and this is tension. So yan lang ang magiging problema mo pag T-beams. So in solving for T-beams, so for this example problem, so determine the design strength of the T-beam shown given that the concrete strength is 27.5 megapascal and the steel strength is 414 MPa. So the given, so FC prime 27.5 and the Fy is 414 MPa. So yan. So the given, ano yung mga given? So andyan naman. This is 628 mm. So tama. So we solve now for the effective depth using the given. So D equals the height, the total height is 700. Pero isubtract natin yung kalahati ng flange. So we assume that first, yung neutral axis mo is nandito siya sa taas. So that is the first step. So this is now the value of alpha. Diba? The alpha is the distance from the neutral axis up to the extreme fiber of the compression. Your D, so mula dito sa centroid ng bakal up to extreme fiber. So this is your D. So 700 less 50 less 28 less 25 over 2. Kasi centroid nito. Ayan. So we can compute ilan yan? 609.5. Your area of steel is pi over 4, 28 squared times 6 That is 3695 square mm. So first, assume steel yields. So we can use the value of your Fy if steel yields. So that is C equals T. So 0.85 FC prime, area of concrete, that is equals to area of steel Fy. 0.85, what is FC prime? 27.5 times area of concrete is 3695 multiplied by 414. Pa-compute ano ang area of concrete na nakuha ninyo? Pa-calculate ako. For 2.99 mm square. That area of concrete is ito yon, yung shadean ko. Ito. Yun yung area ng concrete. And from that, we can solve now for alpha, di ba? Given yung width na 1.2 meters, we can solve for alpha. So that is area of concrete is equals to base of the flange multiplied by alpha. So alpha equals the base of the flange over the area of concrete. Diba? So this is 60, area of concrete, I should say. 65,442.99 divided by the base of the flange, 12 mm. Because this is mm squared. So cancel. Alpha equals
54.54 mm, sir.
ilan? 64?
54.54
54
po.
mm. Okay, so now we have to check if steel yields. So we can now use the formula C equals alpha beta 1. So that is equals to 54.54. From your table, the value of beta 1 is 0.85 sa mga table natin. So C equals
64.16.
64.16. So we can now solve for Fs, that is equals to 600 D minus C all over C. So 600, what is D? 609.5 less 64.16 all over 64.16. So what is Fs?
5,099.81.
99.81. So that is greater than Fy. Therefore, what is our conclusion? Still yields, di ba? Kasi mas mataas siya sa Fy. So we are correct in assuming that still yields. So paki-check yung mga computation natin before I go to the next page. So C equals T, area of concrete is 65. And we are also correct in assuming that the neutral axis is within the flange because yung alpha na nakuha natin is 54.4. Ang height ng flange is 100. So mas mababa siya sa 100. So nandito yung neutral axis. Pero kung sakali lang na ang alpha ay greater than dun sa
Height.
what do you call this? The height of the flange, which is 100, ibig sabihin bumaba yung neutral axis. So andito siya sa baba. So you need to recompute again from the beginning. Kasi yun yung ina-assume natin in the first place. Pero kung mali yung assumptions, katulad nito, pag hindi siya still yields, balik ka ulit dito sa number 1. Pero ang gagamitin mo instead na FY is FS. Okay, so tama naman lahat ng computation. Wala namang ibang nakakuha sa inyo ng ibang computation. So let's continue. So after that, number 4, Fs, since Fs is greater than 1,000 MPa, the failure is tension controlled. So meron ulit tayong table dito. Meron yung compression controlled, tension controlled, and what do you call this? Transition. So if tension controlled, your phi is 0.9 from the table. So number 5, we can now compute for phi mn, or the design strength. Wherein, so it can be tension multiplied by D minus A over 2, or compression D minus A over 2. Any of the two, you can choose. So if tension, ang gagamitin natin, so phi mn equals tension D minus A over 2. That is equal to AS, so it still yields Fy D minus A over 2. So your phi mn equals 3695 414 609.5 less 54.54 over 2. So what is 3 mn? You include the phi, so that is times phi. What is phi? 0.9. So meron pang phi, sorry. I forgot the phi. Meron pang phi. Ilan? 228. This is Newton mm. Or you can convert for kilonewton meter. 801.6 kilonewton meter. So this is now your design strength. Ibig sabihin, yan lang ang kayang hawakan ng beam. If the moment, or if the actual moment na kinikerry ng beam mo is greater than this moment, babagsak yung beam mo. And ang first na magpe-fail is the steel, because the steel yields, no? So that is the answer in the design strength of your T-beam. Okay, take a picture. So how about if the beam naman is, or the neutral axis of the beam naman is below the flange? So determine the design strength of the T-beam shown given that the concrete strength is 27.5 megapascal and the design strength is 414, wherein the base of the flange is 750, the thickness or the height of the flange is 100, the effective depth is 600, and the base of the width or the BW is 360 mm with 828 mm reinforcement. We have FC prime 27.5 MPa and FY is 414 MPa. So C equals T. So assume tension yields 27.5, area of concrete equals AS 8 pi over 4, 28 squared 8 FY 414. Ilan ang area of concrete? Ilan? Ilan ang area of concrete? Ilan ang area of concrete natin? Two 45, 82. And kindly compute for the area of the flange. That is equals to base of the flange multiplied by the height or the thickness. 750 times 100. Ayan, 750, 100, 75. So, ibig sabihin, 75,000 lang yung area nung nasa taas. Ito. Pero yung area ng concrete daw is 87,000. So, ibig sabihin, kukuha pa siya dito. Meron pang makukuha dito na part. So, what is that part? So, ilan ang makukuha sa kanya? So, yung sobra niya, that is 87 to 45.82 less 75,000. i-divide mo siya ng, so let's say this is x. So x equals 360. So more or less ilan ang x?
34.02.
34. 34 so mm. So therefore, your neutral axis is andito. And the value of alpha is ito, which is equals to 100 plus x, which is equals to 134 mm. Your value of alpha. So alpha equals 134 mm. You have two options in treating these T-beams. Pero yung iba, ang karamihang ginagawa nila is mas madali kasi yung centroid kapag ganito ang hati mo. Then we have here the flange. So hinahati nila as ganyan. Yung iba, ang pagkahati naman is kinukuha nila yung top and then kinukuha nila yung sobra. So kapag ganito, ang centroid nito is nandito and then ang centroid naman nito, itong rectangle na ito is andito. So yeah. So let's say, let's take this analysis, yung itong part na ito. So kapag ito, we have two compression. Meron yung dito sa centroid ng sa taas, we have C1. And then yung centroid naman dito is we have compression 2. Then yung centroid ng steel is we have tension. So yeah. So we have alpha is 134 mm. So we check if steel yields. So dito pala, nakalimutan natin, assume steel yields. So check if steel yields. So we have C equals alpha beta 1. The value of alpha is 134. The value of beta 1 is, since FC prime is less than 28.85 pa rin. So your C equals ilan? Ilan ang C?
157.65.
157.65. So Fs equals 600. D minus C over C. What is D? 600 minus 157.65 divided by 157.65. So Fs equals
1,683.54.
so that is greater than Fy. Therefore, steel yields. And since Fs is greater than 1,000 MPa, therefore the failure is tension controlled. Therefore, your phi is equals to 0.9. Question so far? So next, So let's say we have an analysis. So we have C1, then we have C2, then T. So your MN now is equals to phi. We have C1. What is the moment arm of C1 to T? Let's take moment at T. So your moment arm, take moment at T. So your moment arms from C1 to T is D minus T over 2. Tama ba? And then your moment arm at C2 to T is D minus A over 2. Because ito yung T mo, ay yung A mo, yung alpha. Yan kung ganyan ang analysis mo. And how about kung the other way around? So halos sa moment arm lang naman yung kaibahan niya. So pag ito is we have C1, pag ito is we have your C2, and then the tension is T. So kung ito naman yung kwan mo, this is D minus T over 2. Pag ito is D minus T minus yung half nung tawag na ito, alpha minus T, di ba? Alpha minus T over 2. So yan yung moment arm mo naman. Pag ganyan yung hati niya. Pag ito naman yung hati niya, so ito naman yung centroid ng dalawang rectangle. So yan, ang moment arm niya. So we have C1 multiplied by the moment arm D over minus T over 2 plus C2. Moment arm is D minus A over 2. So yan. So your phi is 0.85. Ang common factor niya kapag concrete is the FC prime. So we can factor out the FC prime. So that is 27.5 FC prime. Then quantity. So what is C1? So meron tayong dalawang 100 by 195 multiplied by the moment arm 600 minus 100 over 2. Ba? This is 195. Ito yung 195. So that is 750 less 360 divided by 2. That's 195. So that is the moment arm plus C2. We have 360 multiplied by 134. Times the moment arm 600 less 134 over 2. Yan. Paki-check kung tama if you have any queries. And then compute for phi mn. This is phi mn. .85 FC prime, the area of concrete is 2 times, dalawa kasi to 100 multiplied by 195 times the moment arm D minus T over 2 plus 360, so base times height, which is the alpha, 134 multiplied by the moment arm D minus A over 2. So what is phi mn? Ilan? $880. So how about the others?
Same, sir.
Na-multiply yung fee, ah. Meron ba itong fee? Multiplied by 0.9. 0.9. This is, nakalimutan ko yung fee. May 0.9 pa dito. Point 0.9 is the fee. Ito yung concrete pa lang, yung 0.85 FC prime. So multiplied by 0.9.
992.
992.
168892.
892 Newton mm. Or 992.2 kilonewton meter. So this is the design strength. So any queries? So ganun na. It's up to you kung paano nyo hahatiin pag ganyan. No? Pwedeng ito, yung ginawa natin, or yung isang pagkahati niya is isa sa taas, isa sa baba. Yung sa compression. So pwedeng itong isa, then pwedeng ito yung isa. So ang ginawa natin is ito yung pagkahati niya. So any question or clarification before we go with the doubly reinforced? Okay, kung clear naman, so let's go with the analysis of your doubly reinforced beam. Doubly reinforced. So your analysis of a doubly reinforced beam. So given the following data of the doubly reinforced rectangular beam, so we have a beam width of 410, overall depth. So overall depth, magkaiba siya sa effective depth. So overall depth is 650. The tension bar is 28 mm. Compression bar is 320 mm. So kulang ata to. Hindi na. Okay, sige. 28 mm. Then we have a compression bar at 3 pieces 20 mm. The concrete strength is 20.7. The strength of steel 345 MPa. Clear cover is 10 mm. So meron kang clear cover na 10 mm. So clear cover din sa taas is 10 mm. Stirrups is 40 mm. So meron ka pang stirrups para dito. So in actual scenario kasi, so i-draw ko na lang. Kapag singly reinforced kasi sa actual, hindi mo naman malalagyan lang ng bakal sa baba. So let's say we have here ito. Then we have a stirrup. So yan. So again, this is 410 mm. The total depth is 650. Ang clear cover is the stirrups, from the stirrups. Is 40. And then meron kang stirrup na 10. So yan. 410, 650, 28 mm bar. Then tatlong 20 mm sa taas. Okay. So for doubly reinforced beam, merong humahawak na compression side dun sa part ng steel. So if this is your neutral axis, so our diagram now will become, so this is effective depth from the centroid of the tension side. Yan. Then meron ka rin sa concrete. So this is your concrete due to, so the centroid, concrete due to, compression due to concrete. And then ang nadagdag ngayon dito is we have, dito sa centroid ng compression, meron ka ngayong compression due to steel. So yan ang magiging stress diagram natin. Meron ka ngayong tension, meron ka ngayong compression due to concrete, and compression due to steel. So the compression due to steel, let's say that is CS, is equal to AS prime, yung area ng compression steel, saka yung FS prime, yung yield strength ng compression steel. So parehas lang naman, the compression due to concrete is equals to 0.85 FC prime alpha B. The tension is equals to AS FS. So palitan lang yung FS ng FY if steel yields. So letter A, compute the balance steel ratio or the balance steel area. Balance steel area. So we have first, what is FS? So we need to compute for FS first. 600 D minus C over C. Wherein that is equal to Fy if we assume that steel yields. So therefore, the value of C is still yields. Because a balance, when we say a balance, the concrete and steel yields at the same time. So we equate that to Fy. So your value of C, if we disarrange it, is 600 D over 600 plus Fy. So your C now will 600. What is D? Di pa natin na-compute ang value ng D. What is D? So that is equals to 650 less 40 less 10 less, kasi sa centroid ang D. So centroid nung tension steel. So this is D. Less, ano ang tension? 28/2. Ilan ang D? .586. So 586. Nakuha kung paano kinuha yung D. That is the distance from the extreme compression up to the center of or centroid of the tension steel. So that is 600 plus what is Fy? 345. The value of C is
372.06.
372. So we can compute now for the value of your alpha, that is beta 1C. Beta is less than 1,000, so that is 0.85 pa rin, multiplied by 372. So what is the value of alpha?
316.2.
316.2. Yeah. That is for the value of the tension. Because in the balance is still, what you call this, the balance condition, the concrete and steel yields at the same time. Pero hindi nangangahulugan na the compression steel also yields, itong nasa taas. So hindi natin sigurado kung compression steel yields. So we need to compute if the compression steel will also yield para malaman natin kung ano ang gagamitin natin dito sa CS or C sub S. So we need to find Fs prime. That is 600 C minus D prime over C. And what is D prime? So mula dito sa top hanggang dun sa tension, ito ang D prime. So D prime is top up to the centroid of your compression. So we have D prime equals, ano yun? 40 plus 10 plus half nung compression bars, 20/2. Ganyan. 40, 50, 60. So that is 60. So Fs prime equals 600. What is the value of C? 372. Minus D prime, that is 60 over 372. So what is Fs prime?
503.23.
503.22 MPa. So still also yields. So we can use both Fs and Fs prime to be equal to Fy. Kasi still yields on both. So you take a picture, then next page. So 600, 372, alpha is 316, then D is 586. C is 372, alpha is 316.2. Yan. D is 586. D prime is 60. So we can now equate the three. So we have compression due to concrete plus compression due to steel is equals to T. So 0.85 FC prime alpha B plus AS prime. We can now use for Fy because it still yields. Then we have the AS balance, or the balance is still area, and then Fy also. So that is 0.85, 20.7, what is alpha? 316.2, what is the value of B for 10? Plus, what is AS prime? AS prime, 320. 3 pi over 4, 20 squared. Fy, 345. Equals ASB, 345. So what is the balance steel area? And then necessary. I don't compute for the number o ano bang compression na high tension transmission 28 mm. Number of 28 mm bar. So that is 7554.22 divided by isang area na 28 mm. Ilang 28 mm dapat. Well, wala namang 27 na 28. So 12 is expected. So ibig sabihin yan yung number dapat ng tension bar para alas lang yung beam mo. So meron ka ganda yun. Itong compression tatlong number saka 12. So, paano mo ayusin nyo? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pwedeng ganyan. So, dapat lang yung ratio mo. 12 na 28 mm, isang tatlong 20 mm. So, balance condition. So, 75.4 or 12 na 28 mm bar. So, enter. Next, compute the design strength of the beam using 3 28 mm tension bar. So, using, nagkaroon naman but is the design strength or the design moment. So we have 328 mm tension, 328. Sa taas, we have 320 mm. So what is now the design strength? Also, in the learning still deals, we can compare it with the ES balance. So kung what they call this, the area na nakuha mo is less than ES balance, still yields. So we can compare the balance condition. So we can compute it for the area. We have ES prime. So ES prime ito, ES isang basta prime ang pressure side na. So we will be multiplied by 4 20 squared. Ilan?
Nine four two point 48.
942.48 mm square. Then ES equals 328 square. Naman. I'm sorry, this is for na. For tension lang to. This is ES component analysis. So this is greater than or less than ESB. So still yields. Now check the compression still yields. So ang sigurado lang natin the tension side is only on tension condition. So we have to compute for the values. So we have to assume compression still yields. Yung compression ang yung problema naman pag pag-reverse kasi. Hindi natin sigurado kung mag-yield siya or hindi. So assume compression still yields muna na. So CC plus CS equals C. So that is 0.85 F6 line alpha for 10 plus 9.42.48. Assume still yields muna na. So 3.45 equals the tension side is still yields naman talaga yun. 18.47.26 3.45. So what is the value of alpha? Ilan na value ang alpha? 0.27. Then compute for C, that is equals to alpha divided by beta 1, 43.2.85. Ilan lang?
6.91.
991. Then you can also now for your FS prime for the compression. 600 C minus D prime over C. 600 50.991 is plus D prime. And then that is 40 plus 10 plus 10. So 60. 50.991. So FS prime was FS prime. Ilan lang? Okay, 13. Feeling basta yun. Kasi nakakapin na yung individual. So, parang posible naman so we'll just deal with. Therefore, we go back to step number 1 sa ilalog na natin. So, balik pa tayo dito sa formula na ito. Pero ang gagawin na natin is FS. Kasi hindi natin binag-build dito. So, hindi mo na compute. Compute natin. So, C plus CS equals C 0.85 FC prime. And now, alpha. You have alam. So, 0.85 C. 410 B. Plus, we have CS prime. Na 442.25 FS. We have 600 C minus 6C over C equals to 18.7 3.5. So what is now the value of C? Ito pinalitan ko na ng SF kasi point yan 85 FC prime alpha B plus DSS prime FS prime dash D. PS, FY. So what is the value of C? Yung question or not around 0.2557. Para we can solve our source. Point for sources. Then y equals 0.25 times 18.4. Ganun for sources.
It's 80.59.
Then you can compute it now. 39. Fs prime equals 600. 600. Since C na lang natin is greater than dun sa what we call this yung kanina yung 40 plus 10 plus 10. So mas mababa na siya doon. Ibig sabihin balik na natin. So only minus C over C. So that is 600. Sorry pala. Kasi mas mataas. 60. So, sabi na, babalik pa rin yung pag mas mababa siya. So, parehas C minus E prime over 7. So, this is 80.46 minus 60 over 80.46. So, what is Fs prime?
152.57.
152.57. So, correct naman kasi less than FY. So, C does not yield. Then also for FS, for tension on 600 D minus C over C. For 600, what is the effective depth? 556 minus C for forces over 80.46. So Fs equals ilan sa tension? Correct pa rin yung assumption natin. Mas malaki sa Fy, still yields. So sa tension, still yields. Sa compression, still does not yield. So we can now compute for Phi That is equals to, what is your fee? Again, it is tension control, so 0.9 pa rin. So what is your CC? So this is compression due to concrete. Ang moment arm, so this is tension. This is for compression due to concrete. Saka meron kang compression due to steel. Yan. So magmo-moment tayo pa rin sa P. Moment at tension. So we have the moment arm. Ano ang CC? That is, anong moment arm niya? D yung buo minus ano to? Alpha over 2. Ang moment arm naman ng compression due to steel is we have D yung buo minus D prime. So CC, D minus alpha over 2 plus CS, D minus D prime. So this is equals to 0.9 quantity 0.85 FC prime alpha, ilan na yan? 68.4 B 10 for 10. Then we have D 586 less 68.4 over 2 plus 942.5, then 152.8 multiplied by the moment arm 586 less 60. Uh, 152.6 pala ito. 152.57. So this is FS prime 0.6 or 0.57 na lang. 152.57 ito. So what is PMN? Point 9 quantity, 0.85, 20.7, 68.4, 410 quantity, the moment arm for 586 less 68.4 over 2. Plus your CS is 942.5 multiplied by 152.57 multiplied by the moment arm 586 less 60. It's 71 287, ganyan, 68 671 287.49 or 68.7 kilonewton meter. So can you check na multiply na ito 0.9 yung fee? May 0.9 pa siya dito sa labas. This is yung, ito yung naka-bracket ha. Yan. Yung naka-bracket multiplied by 0.9. Okay, so tama? Any question, clarification? Questions or clarification? So wala so far. So 68.7 kilonewton meter. So that is if using 328 mm. So review lang natin ulit. So first, check if tension still yields by comparing AS with AS balance. If AS is less than AS balance, tension still yields. Second, assume compression still yields. How do we do that? That is CC plus CS equals T. So we can solve for alpha, we can solve for C. And then we can check if compression still yields. We can compute for Fs prime, that is equals to 600 C minus D prime over C. So if compression still does not yield, go back with step number 2, but this time use Fs prime equals 600 C minus D prime over C, and alpha equals to C beta 1, and compute for alpha ulit, compute for C, compute for alpha, compute for Fs prime ulit, saka compute for Fs. If compression still yields, correct assumption. Proceed with number 4. So sa number 4, check or determine the type of failure, if it is compression controlled, tension controlled, or transition. So that we can know the reduction factor phi. And then lastly, we can now compute for phi mn. So your assignment is letter C. Compute the design strength of the beam using a 628 mm diameter tension bar. So the same given, the same B, the same H, the same compression bar, which is 320 mm. But now you will now use 628 mm tension bars. So any question, clarification before we end the session? So this is review again. So first, check if tension still yields using or comparing the area of the tension still with the balance still ratio. And if the result is if AS is less than ASB, tension still yields. Then assume compression still yields, that is using the equation compression due to concrete plus compression due to steel equals the tension. So we can compute for the alpha and C. Then check if compression still yields. by computing for the Fs prime. If compression still does not yield, go back with number 2, recompute for alpha, recompute for C, recompute for Fs prime, recompute for Fs. If compression still yields, we have a correct assumption. We can proceed with number 4. That is determining the type of failure to know the value of the reduction factor phi. And the last step, we can now compute for PMN by taking moment. Actually, itong taking moment, hindi naman siya, tawag na nito, hindi naman siya sa tension side lang pwede. Pwede rin sa compression, kaya lang mas complicated kasi yung moment arm. So this is tension, this is CC, this is CS. Pwede kang mag-take ng moment at CC. Pwede yan. And then your, tawag na ito, your VMN now becomes CS minus T. Kasi magkaiba sila ng direction. So we can take moment also at CS. So CC minus T. Or we can take moment at T, that is CC plus CS. Kung taking moment at tension. So that ends our lecture. So any question or clarification before we end the lecture? Denzel Galapon. So if you have no more clarifications, thank you very much for attending this session and see you on next meeting.